For part 2 of this video, we're going to start talking about limits by analyzing their behavior coming from the left, coming from the right, and then using a logic test to say, is the limit coming from the left the same as the limit coming from the right? If it is, then the overall limit will exist at that location. So let's look at example 3. Example 3 is a function, okay? It is a function where if I take this information that you see here, okay, this would be the corresponding graph. You would not have to generate this on your own, the textbook, or I would have to give this to you. Okay, but let's first talk about what if we are asked to evaluate the limit as x approaches 0 from the left. 0 negative means from the left of the function absolute value of x over x. Okay, so here's how this works. I'm going to use colors for this to explain it. So this is going to be 0 from the left. So here's 0. This would be the point that they were referring to, but I'm going to be talking about what happens as I come across this way on the graph from the left approaching the 0 point. I know it's undefined, but right before that, what's happening? To me, it looks like this blue is approaching the value of -1 as my y value. Okay? But now if I look at and have to define what happens when I want to talk about the limit as x approaches 0 from the right of the absolute value of x over x. Okay, so 0 from the right. Here is 0 again, but now I'm talking about this part of the graph because I'm approaching from the right side. This looks like it's approaching 1. Okay, so think of it this way. Here's the blue, here's the pink. They are approaching different points. The y values, the limit from the right is 1, the limit from the left is -1. Since these are not the same, we can say that the overall limit as x approaches 0 of the absolute value of x over x does not exist. And it doesn't exist because these are not the same value. They must be the same from the left and from the right. Let's do another example. Stay with me. So, the question in example 4 is, why doesn't it exist? And the reason is because, and I'm going to write this in math language so we get used to using calculus language, the limit as x approaches 0 from the left does not equal the limit as x approaches 0 from the right. They are not the same. Okay, so if you want to in your notes, you can verbally take what I'm saying, translate it, and write it out in words. This is the math language for it. Again, the limit as the function value of x approaches 0 from the left is not the same as the right. Here it is. From the left it's -1, from the right it's +1. Okay, so now how can we just practice finding one-sided limits? See if they exist or not. Let's start with the first one. This is my f of x. What is the limit as f of x approaches 3 from the left? So here's how that works. I go to 3. I come in along the left. It looks to me as though that is approaching the number 4. Now I want to do 3 from the right. So here's 3, I go up, I'm looking this way, that looks like it's also approaching 4. So now I'm going to go up to this idea that I was talking about up top. Are these two limits the same? If they are, then the overall limit exists. So the limit for f of x, as x approaches 3, notice there's no positive or negative there, is also going to be 4. It's because these are the same. Okay, I'm going to put a happy face, makes people happy when these are the same. Now if we take a look at b, and we talk about what happens when it approaches 3 from the left. Here's 3. This is my point coming in from the left. That looks like -2. But what about from the right? 3 plus means coming in from the right. We're going to go this way. That is going to be a 4. These two things are not the same. So when you're asked to evaluate what is the overall limit of the function at 3, it does not exist. Okay? Now, I do want to put a little note here. You may be asked, what is f of 3? Okay? This is a function. Go to the f function. When x is 3, what is y? Here's 3. The function is defined at this point right here. So the answer is going to be 4. Yes, this exists. However, it is not the limit of the overall function. The limit can only exist in the case where they approach the same value from left and right. These are two different mathematical concepts. Limit is about coming from two different sides. Is it approaching the same number? The value of a function at a given x value is just an algebraic concept. Input in, what is the output out? It is not the same. There is no logic test when we are doing f of 3. Right? Take a look at part C. In part C, the limit from the left is going to be coming down this way. Looks to me like it's -2. Coming from the right in this direction, it's also -2. These are the same. Since they are the same, the limit at 3 overall exists, and it's defined as -2. But again, I'm going to ask you an algebra question now, not a calculus question. I'm going to ask you, what is f of 3? F of 3 is not -2. It's not defined down here. F of 3 is actually going to be 4 again. This has nothing to do with limits. This has to do with the algebra concept of the point that is defined. All right, last two examples from the actual notes. All right, investigate graphically and numerically what's going on with this. Okay, here's what this says. The limit as x approaches 0 of the graph of sine, this is my function, 1 over x. You can put it in your calculator, but most of these problems are going to be something that happens in a book. This is an oscillating function. So it's going to come down. It's going to look really weird. And then it's going to do this. It's going to waver and waver and waver and waver and waver. And then it's going to do this and come out this way. Okay? When we say oscillating, this is going to go up and down like an accordion, back and forth, back and forth, back and forth, back and forth. And the idea is that as you zoom in and stretch this out, it's going to keep oscillating more and more and more. No matter how much you make the interval smaller, you're just going to see oscillating curves. It never stops oscillating. So we are going to say in an example like this, where the more you zoom in, it doesn't approach a single value, the limit as x approaches 0, so from the left and the right, of the function sine 1 over x does not exist. Okay? But now we should be able to talk about example 7. Okay? Example 7 is going to be what we call an infinite limit. Okay? Infinite limits. So 1 over x is a rational function. It looks like this. And it looks like this. And if you remember from our last unit, this function has two asymptotes. It has one here, and it has one here. Vertical and horizontal. Okay? So now if we talk about the limit as x approaches 0 from the left, do you know where in the graph I'm talking about? Here is 0. What I'm talking about is, what is the behavior as this graph continues to trend downward to the ground? I'll do that again. What is the ultimate y value all the way at the bottom off of the page? This is going to represent negative infinity. It's going down. Continue down. But if we look at the other part, what is the limit as x approaches 0 from the right? That's going to be this part of the graph. This is going to go up. Yes, I did change my sound effect. Up. The biggest number you can think of is going to be positive infinity. Are these the same? This is the smallest number. This is the biggest number. I don't think they're trending to be the same value. These are different. So overall, the limit, these are not the same. So overall, the limit does not exist. So the limit as x approaches just 0 in general, it does not exist.